March 11, 2011, a date etched in history. Off the coast of Japan, the seafloor heaved. A colossal magnitude 9.0 earthquake, one of the most powerful ever recorded, unleashed a force of unimaginable scale.
The ground
Shook violently for 6 long minutes, toppling buildings and tearing apart infrastructure. But this was only the beginning. The real catastrophe was racing toward the shore. A monstrous tsunami with waves reaching up to 133 feet slammed into Japan's northeastern coast. It was a wall of water, a liquid battering ram that swept away everything in its path home, cars, entire towns. In the midst of this devastation stood the Fukushima Daiichi nuclear power plant, a facility designed to withstand earthquakes, but not a deluge of this magnitude. The plant's operators felt the quake and did exactly what they were trained to do. The reactors in operation automatically shut down, a process called a scram. Control rods were inserted, halting the nuclear fission chain reaction. This was textbook procedure, and for a moment, it seemed like the plant's safety systems had worked perfectly. But the real danger wasn't the shaking, it was the water that followed. Even with the fission process stopped, the nuclear fuel inside the reactors remains incredibly hot. It continues to generate what's known as decay heat. And if this heat isn't constantly removed, the fuel rods will overheat and melt. This is why nuclear power plants require a constant, uninterrupted supply of power to run their cooling systems pumps that circulate water to carry away that intense heat. Fukushima Daiichi had multiple lines of defense. When the earthquake severed the plant's connection to the main power grid, its emergency diesel generators roared to life just as they were supposed to. These massive engines housed in the basements of the turbine buildings took over the critical job of powering the cooling pumps. For about an hour, everything was under control. The plant was stable, despite the chaos outside. Then, the tsunami arrived. The plant's seawall, designed to protect against waves of about 19 feet, was utterly overwhelmed. A torrent of seawater surged over the wall and flooded the site, poured into the turbine buildings, right where those crucial emergency diesel generators were located. Water and complex electrical machinery do not mix. One by one, the generators were swamped and failed. The plant was plunged into darkness. This was the moment the crisis truly began. Station blackout. No external power, and now no emergency power. The main control room, which had been a hub of calm, focused activity, now faced a terrifying reality. The instruments and displays that told them the status of the reactors started to go dark. The pumps that circulated life-saving cooling water stopped. The heart of the plant had stopped beating. Without cooling, the temperature inside the reactor cores began to rise, and rise, and rise. In the darkness, with limited data, the engineers and workers on site scrambled to find a solution. They were battling the clock, trying to prevent a full-scale meltdown. The pressure inside the reactor containment vessels started to build to dangerous levels as the water boiled away into steam. The problem was immense. They needed to get water into the reactors, but they had no power to pump it. They tried to use mobile generators and even fire engines, but the debris, the darkness, and the ongoing aftershocks made every action a desperate, heroic struggle. The workers were exposed to increasing levels of radiation as they tried to manually open valves and connect hoses, fighting a losing battle against the laws of physics. As the nuclear fuel rods became exposed, their zirconium alloy cladding reacted with the superheated steam, creating a volatile mix. Hydrogen gas. This gas began to accumulate in the upper parts of the reactor buildings. The pressure needed to be vented to prevent the containment vessel from rupturing, but venting would release radioactive material into the atmosphere. It was a choice between two terrible options. They vented the pressure, but it was too late to prevent the inevitable. On March 12th, less than 24 hours after the earthquake, the accumulated hydrogen gas in the Unit 1 reactor building ignited. A massive explosion blew the roof and walls off the building, leaving the reactor's inner containment exposed. The world watched in horror as images of the shattered building were broadcast globally. Over the next few days, the same thing happened at Unit 3 and Unit 4, a series of catastrophic hydrogen explosions that signaled the loss of control. Inside the reactors, the fuel had melted. It slumped to the bottom of the reactor pressure vessels, a molten, intensely radioactive mass called corium. In some units, it's believed this molten fuel burned through the steel pressure vessel and pooled on the concrete floor of the primary containment structure. A full meltdown was no longer a risk, it was a reality. The focus shifted from prevention to mitigation. A desperate effort began to cool the molten cores by any means necessary. They started pumping seawater directly into the reactor's elastage. It's an irreversible decision that would contaminate the plant and the ocean, but was essential to stop the situation from getting even worse. Helicopters flew overhead, dropping tons of water onto the damaged buildings, trying to cool the spent fuel pools, which were also in danger of boiling dry. The Japanese government ordered a massive evacuation. Over 150,000 people were forced to leave their homes, creating an exclusion zone around the plant that, in some areas, remains uninhabitable to this day. They left behind their lives, their possessions, their communities, not knowing if they would ever be able to return. The Fukushima Daiichi disaster was a chain reaction of failures. It was triggered by a natural disaster that exceeded all design expectations. It showed that even in a country known for its technological prowess and meticulous planning, a cascade of events, the loss of grid power, followed by the flooding of backup generators, could lead to a worst-case scenario. It wasn't just a technical failure, it was a failure of imagination, an inability to foresee a disaster of this combined scale. The cleanup at Fukushima is an unprecedented challenge that will take decades, maybe even a century, to complete. It involves decontaminating vast areas of land and managing millions of tons of contaminated water and soil. Robotic technology is being developed to go into areas where humans cannot survive, to assess the damage and eventually remove the melted fuel. The event sent shockwaves through the global nuclear industry, forcing a worldwide reevaluation of reactor safety protocols. New regulations were put in place, focusing on what are called beyond design basis events, catastrophes that go beyond what a plant was originally built to handle. The focus shifted to ensuring robust, multi-layered backup power systems that can survive flooding and other extreme events. The story of Fukushima is a powerful and humbling reminder of the immense power we wield with nuclear technology, and the profound responsibility that comes with it. It's a story of nature's overwhelming force, human ingenuity under pressure, and of the long-lasting consequences when our creations fail. The lessons learned from those fateful days in March 2011 continue to shape our approach to energy and safety, ensuring that a disaster like this will never happen again. Thank you for watching. If you found this story compelling, please like and subscribe for more deep dives into the events that shaped our world.